Welcome to Archive Mind, your memory palace for mastering difficult concepts where we turn complex topics into simple bite-sized lessons you'll never forget. This video is part of a wider series in the Geography playlist. Today we'll be exploring the ocean. Let's dive in. Imagine if Earth had a secret superhero. Not the forests, not the sky, but the oceans, silently working 24/7 to absorb our carbon emissions, feed billions, cool the planet, and cradle entire ecosystems. But now that hero is under attack from the very species it tries to protect, us humans. For centuries, humankind has regarded the vastness of our oceans as an inexhaustible source of food, a useful conduit for transporting goods, and a convenient dumping ground for waste, too immense in size to be susceptible to our environmental negligence. But human irresponsibility is pushing our oceans and the life support services they provide to their limits. So, our ocean as a carbon sink. Well, oceans absorb approximately 30% of CO2, carbon dioxide, from the atmosphere. The ocean absorbs CO2 through both physical and biological processes. Physically, CO2 dissolves directly into the surface waters. Biologically, phytoplankton and zooplankton, microscopic marine plants, all help to absorb CO2 through photosynthesis, the process of converting sunlight into food. The ocean's role as a carbon sink is part of the natural carbon cycle, which is a continuous movement of carbon between the atmosphere, oceans, land, and living organisms. Some of the carbon absorbed by phytoplankton is transferred to the deep ocean through the marine food web and food chain and the sinking of organic matter. This process effectively removes carbon from the atmosphere and stores it in the deep ocean for extended periods. Fun fact, phytoplankton absorbs more CO2 than Earth's trees combined. You can think of it as the Aquaman of the sea, fighting off villains, human-induced carbon emissions, in its very own terrain. Something even the great tall-standing tree heroes can't do. The ocean absorbs a substantial amount of human-generated CO2, helping to slow down the rate of global warming. The ocean also produces roughly half the oxygen we breathe, making it crucial for life on Earth. So what is the main problem at hand? Well, we are pushing our oceans to its limit, as mentioned before. Overexploitation of marine ecosystems through activities such as ocean trawling and fracking damage the ocean bed, kill off marine life, and releases CO2 into the atmosphere, contributing to climate change. Population growth and demand for natural resources such as oil and gas, as well as the rising affluence of adopting a diet rich in fish, leads to overfishing and destroying marine habitats and further the seabed floor. Ocean acidification is when a decrease in the pH level of the Earth's ocean is primarily caused by the absorption of excess carbon dioxide from the atmosphere. This weakens coral structures and leads to coral bleaching. Think of it as it's like brushing your teeth with lemon juice every day. The enamel or coral erodes. Eutrophication is another issue that occurs as a result of excessive use of fertilizers and pesticides that run off, leading to excessive growth of algae and other aquatic plants. This overgrowth can deplete oxygen levels, harm aquatic life, and potentially even humans, as well as disrupt the ecosystem, plus result in economic losses in billions for fisheries. Now, where does global governance come in? Well, so UNCLOS is an example of an organization that has influence over its member states, regardless of national boundaries. It enforced the 200 nautical mile exclusive economic zone, EEZ, which are zones where coastal nations have jurisdiction over natural resources and economic activity, such as mining resources and fishing. The high seas are where no single nation governs, and the South China Sea is one of the most important yet contested ocean spaces in the world. There are repeated territorial claims and disputes over political ownership of its many small islands and its waters. Oil exploration has led to many marine dead zones, resulting in vast amounts of depleted marine stocks, affecting local communities and fisheries. Oil transit choke points are critical for maintaining global energy security. These are narrow channels along key trade routes, which need to be kept open if the movement of oil is not to be disrupted. These oil transit choke points are vulnerable to accidents, oil spills, and marine piracy that can have devastating consequences for marine life and habitats. Additionally, the world is dependent on underwater seafloor cables. 99% of intercontinental data traffic is transmitted through these cables, and the demand for global bandwidth is growing at up to 40% per year. But what does this mean to the health of our oceans? Well, yet again, it disturbs the seabed and natural marine habitats. Marine life could get entangled in cables similar to fishing nets. The magnetic fields can affect sensitive species like sharks. In some cases, the natural ecosystem can be altered as a result of potentially attracting certain new species. So, how do we go about solving this problem? Well, it's definitely not easy for sure. Whilst we can introduce and designate marine protected areas and start blue carbon projects, a collaborative effort is needed to make this work. It's definitely not easy to stop people having a fish-based diet, but regulating overfishing and deep-sea mining through fishing quotas is possible. To reduce oil pollution, tankers are prohibited now from flushing out empty tanks with seawater and pumping it into the sea. International and environmental organizations can further raise awareness of ocean issues and provide long-term conservation and sustainable use of marine resources in the deep sea. Aquaculture production is an alternative to traditional unsustainable fishing methods. However, it brings some concerns on risk of outbreaks of diseases due to cramped conditions of fish. Campaigning and consumption is also a potential solution. Remember when I mentioned eutrophication and ocean acidification? Well, using fertilizers responsibly and employing crop rotation can help prevent eutrophication from happening. Reducing carbon emissions through the burning of fossil fuels can help prevent ocean acidification. And that's a wrap. Follow Archive Mind for more bite-sized lessons that make complex ideas memorable. As always, drop down any suggestions for videos and see you next time. Thank you.